Hello, all. Welcome back to yet again Friday's fun of the free support session offered by none other than Fusion Phil here at JitCAD Cam. And oh man, am I ecstatic to be here. So, as you guys may or may not know, I am the owner of JitCAD Cam. I perform these amazing acts on our Friday afternoons to provide free support to anybody and everybody that's willing to ask the questions, utilizing the chat feature or leaving a comment at a later date. We also have the ability to do things via email. Now, full disclosure here, guys, if you're going to submit something here, make sure that it's okay for us to publicly show it. We haven't had any problems, at least that I know of, but I want to make sure that in the event that you are providing something from your company, maybe a modified version of it would be wiser than providing the actual. So if you guys can hear me out there and you guys can see me all right, I do want to welcome anybody new as you guys are watching this content or jumping in. As well as we always do every week, we are going to kick off the ceremonial energy drink. Again, rough day today. Started my day at about 4 a.m. Central Time and have been going nonstop ever since. So I'm going to take this moment to crack this guy open and get a little drink in. And from there, we have 4 separate topics to kick this off. Again, at any time, guys, if you have any questions, feel free to throw them in chat so that we know. But let's do this, right? Let's do it. So we're going to go ahead and start with sharing my screen. And what I'm actually going to do is I'm going to go back into the default sample area because I saw a question on Facebook. Somebody was more or less asking about polar milling. Now, I need a very good example part to utilize for this, but I do have video content on this. You guys have seen it on our channel if you've been here before. But basically, anytime we talk about milling on a mill turn machine, this is a good example of that, is I'm going to go ahead and clean this up just a little bit more. We're going to get everything else out of my way. But depending upon your post processor, now a little birdie has told me, take this with a grain of salt, guys, that you won't have to do it this way eventually. But also another little birdie told me at one point that we were going to have ITAR compliant Fusion one day, and that was 8 years ago, right? So I want to show you is based on this particular post. This is the DN Solutions mill turn post. Is if I go ahead and hit the little pencil here to edit this, we have what's called manual NC commands. And what these commands allow you to do is to force things to happen inside the post processor. What I'm going to do is I'm actually going to copy both of these using Control C in this case. And when we go back to the actual software, I'm going to duplicate my toolpath. And the reason for this is because I'm going to build out both scenarios. We don't need to duplicate the entire setup. What am I doing here? Let's go ahead and duplicate just the toolpath. So how we activate that is we're going to go up here to our setup and do a manual NC. And then from there, we want to do an action. And then we are going to paste in, pro tip here, if you guys are using Windows 11, which you should be, your clipboard, if you push Windows V as in Victor, you can grab everything that you've basically copied and pasted that day. So let's go ahead and do our first one here. And then we're going to go ahead and do another manual NC. And we're going to have to double check these because I might be backwards. One is coordinates. One is interpolation. Beautiful. And basically all we're looking to do is put one in front of the toolpath that we want it to activate on. I'm doing both of them at the same time because, again, in the great world of all this stuff that we do over here at JitCAD Cam, there is a time and a place where you just can't remember it all, and it's easier to make sure that you get both birds with the same stone, right? So what you're going to notice here is on that first contour path, I'm getting my XC moves, XCZ. Now, if I rotate down, again, it's going to be dependent on your machine. Get down a little bit further here. As you're seeing further down in my code, I'm trying to find that, there it is we now switch out to XYZ. So again, using a manual NC action, you have the ability to control your mill turn to force things like polar milling or vice versa, depending on your application. Now, that's not to say at the end of the day, there's a lot of other things that go into this. I just want you guys to be aware. Let's go ahead and post this out one more time. And that error that you guys just saw me get just so you're aware, is I have what's called Post to Fusion Hub turned on. And if you guys didn't know this, this is actually a really good thing to point out, is you can post your G code to the team hub. And if you're using the machine connector, we can actually send your code from the team hub straight to the machines. And it also allows you to keep a backup on the cloud in case you ever have to go back to it. But let's go back into that post processor real quick. There's a lot of stuff in a post processor. We have videos on this stuff, but I want to make sure that if you guys were feeling wanting to go out and make some of your own changes, you'll notice is based on your machine build. A lot of times there is things like, does it have a Y-axis? Does it have a B-axis? Is B-axis manual? Again, these are all defined properties that you have control of. Now, some of these also have the ability to limit, your X travel. Can you cross center line? That will affect whether or not you can actually do a part in XYZ or XCZ. So that's just something to keep in mind. I want to put that out there because I did saw that on Facebook and I promised to show it. With that, we do have our first guy in chat. Bogdan, you are here all the time. Bogdan, do you live in the US? Also, secondary, do you own your own machine shop? Because this guy is here all the time. So either he's perfectly timing this in the US on his lunch break, or there it is. It's nighttime in Poland and he's still showing up. Love to have it. So first and foremost, like I showed you guys, just a button pusher. Bogdan, you watch my videos, you will no longer be a button pusher. You may also no longer work for the company you work for because, again, some people just can't afford to give you a promotion, right? But that was our first and foremost, the very first topic of the day. Again, utilizing the ability to do a manual NC to trigger things inside the post processor, like forcing those different types of actions. Now, you do have a few other things here with manual NC I want to point out to you guys. Some people don't realize is one really nice one is that you can go through and you can actually do some pass-throughs, forcing tool changes, starting your chip transport, turning off your chip transport. I don't know about you guys. If you're using certain machines that will not be named, sometimes it's better to run the chip transport once there's a bunch of stuff in there, right? So again, if I had a long 2-hour cycle, do I really need the chip conveyor running the entire time, or do I just want to kick it on at a certain point? So let's go ahead and back out and let's move on to our next subject. We're going to go ahead and pop open my window and I'm going to navigate back to our lovely Free Support Friday folder. And for those of you guys out there, I see you jumping in here. Again, just a reminder, if you have questions at any time, throw them inside the chat. I would also like to know, what do you guys think of all of the content we're doing lately? I see the comments coming in. People are loving the slowed down and simplified type stuff. So the next one I'm going to jump on, this is actually a machine simulation question at the end of the day. So this is going to be a messy file. I'm going to warn you guys, at the end of the day, if you're building machine simulation, please do not build it with all of your components separate. Try to stack up. Yeah, Scott out there in chat's already mentioning this, but Scott, it's okay. We don't always have the best of features here. But Scott, this is what I was referring to when I loaded this file up, is you have all these individual parts that are linked basically to his physical machine. Which again, this is based on like the more traditional, are you designing parts or an assembly kind of stack up? Not a big deal. Little bit of a pain in the ass, but not the biggest of problems. So once I actually got down and found where his part file was, again, I'm not going to blame this all on Scott, guys. This is just the way it imported. Usually when you import something with a machine, it's right there where the file is. But his problem at the end of the day, now full disclosure here, I want to show you guys. I did have to go out and give this a post processor. Again, Scott was so gracious to tell us that, hey, we are running a Siemens control on that Sile machine, which, Scott, let us know in chat. What do you think of those machines? I've heard a lot of good things. Now, I will say it does seem like ever since Haas started dropping the whole mini mill line, that a lot of people have shifted their way over. But that's, I mean, to each their own, man. Any machine that's running in your shop making you money is a good machine, right? So what we're going to do is we're going to simulate his part file here. Or I'm going to Anger Fusion. One of the two is going to happen. We're going to give this a moment. Now, I will say this is one of those things that I am on a higher end computer. However, because of the way the machine sim was built, does actually have a lot to do with how fast it's going to load and how fast you can simulate it. So as you guys saw, there was a delay there. There was some thinking. A good example of this is I don't know how this actual presetter is built out, but if this is a bunch of individual components, it's going to cause a lot of problems at the end of the day. This is why it's nice to go in if you don't need all the details and stuff, is trimming it down, slimming it up to make your life easy. Also, Scott, is that one of those fancy quick change bases that's magnetic where you could just drop it in and drop it out? Haas is getting scared of foreign machines. Titans of CNC clone. So again, I've seen this too. We'll talk about this here in a minute. It's a pretty neat thing if you guys haven't seen. Some machines have started to build it where you could actually put your presetter in for when you need it and then remove it to get it out of the machine. Because if you haven't broke the plunger before, you're not a real machinist. There's two things that we always carry with us at JetCAD Cam when we visit on site. One is probe styluses. The other is this little plunger for the Renishaw probes, because I don't know how it happens, but they always somehow get broken. But let's get back to simulating his part. So his initial issue is if I push play here, you're going to notice he's utilizing the rotary parallel toolpath. We're not going to judge him on that. But at some point, he gets here to the retract and linking. And what's going to happen is you're going to see it's unwinding all of those A-axis motions, right? So again, we can look at the G code here under the information dropdown. As you guys are going to see, is we're going to go down to the NC code. Now I can see my actual NC code. Again, if we go ahead and scroll up in our code, let's go ahead and jump to the line up above. And then again, I'm going to click on screen and drag. So what you're seeing right now is we are having to go, if I could find the last A motion here. Now this is, again, one of those things that we're dealing with Siemens. It's going to look a little different. But as you can see, we ended up at 2,500 degrees, right? Presumably, what's that? 8 revolutions. Who knows the real math on it? But as you're noticing is when we get down here to our next line, we're calling out to go back to 0, but it's requiring the machine to unwind what happened. So what I'm going to do is we're going to go ahead and exit simulation because I want to go back to my machine and I'm going to edit said machine. And with this, we're going to go ahead and look at the kinematics tree. Now, had Scott, no offense, Scott, watched some of our content on building these out. The nice thing is when you go to the rotary axis, because that's what we're concerned about right now, is there is what's called an unlimited range, a limited range, or cyclic. That being said, is a limited range is usually used when you cannot swing that rotary full 360. Good examples of this is when you're dealing with like an AC trunnion style machine for 5-axis. Maybe you're dealing with a trough, which I'm going to pull up kind of like a trough part where we can't swing the rotary 360 degrees because we'll cause a collision of the part with the table. Now, again, we can limit that. That's not going to work for us here because then we will, with limitations, require multi-axis, retract, and reconfigure. So what this is going to do, and this is one of the most, I'd actually say I need to make a list of top 5 commonly asked questions. But to say the least is if you're on a 5-axis and you can't swing that machine a certain way, or you're going to say we can only go a certain angle of tilt, is you have what's called retract and reconfigure. Where this shows up is when you post it out and it says rewind, rewind, rewind. That's the big error, right? So in this case, you just come in and you check this box. But that's not the case here because we know on our A-axis, we have no problem swinging it 360 degrees. So what we're going to use is we're actually going to go to cyclic. And what that is going to allow us to do is output basically multiples of 0 to 360. Now you can change these numbers, but no matter what you change them to, it's still going to rely on 360 degrees. So if we go 10 here, it's then going to go to technically 370 or negative 350. Again, we need that full 360 swing. So I'm going to go ahead and hit OK here. Again, we're going to go back. We're going to hit OK one more time. And now we're going to go and simulate that one more go around. So again, we'll give this a minute to load. We're not blaming Scott. It's not Scott's fault. The only thing that is Scott's fault on this part is the fact that he does not have our lovely top tier support package to help with this. But as you guys will see now, is we'll go ahead and hit play again. We're going to wrap around our part. And then when we get to the end of our code, I am going to pull up our G code one more time. And at some point, you're going to see there was the retract. So let's go ahead and jump. We're just going to do the good old fashioned jump through. There's our retract motion. But if we scroll up here, you'll notice that our A equals DC, kind of our last A motions are at 0.8. So we're past 0, 12 o'clock, but we're no longer basing everything on going that full 2,500 degrees, right? So all these multiples as we scroll up are based on 360-degree multiples, right? So every time we pass 360, we go back to 0. And that's what remedies the fact that when we retract now, we stay in this one position and nothing else happens. So I'm going to go ahead and run this one more time because I'm going to make a few more suggestions to some of you guys out there. One of those is if you notice my starting point on this particular toolpath. So let's get back to our starting point. Where is our first code? So we're actually sitting, and I don't see it here. So we don't have a XY pre-position. So again, this is where we talk about post-processors a little bit, that if you're dealing with a big part or getting out of the way, I'm going to edit this one more time. We're going to edit. We're actually not going to edit the machine. I'm going to have to do this a little different. I'm looking to edit the post-processor, which if you guys didn't know, you can easily access it through the machine. Now, what I'm looking for is kind of easy to Control F and hit the home button. And then from that, we're going to scroll down a little bit because as you can see, we have what's called our retract, right? So this is where we can define when it comes to our XY location based on scenarios. For example, on indexing, do we just want to go up in Z and index, or do we want to go to the home in XY, for example? We could also do things on tool changes, move out of the way as well. Program end, for those of you guys that don't know, do we want to go home in XY, or do we only want to go home in Y and bring the table forward? This is where we can manipulate all of this type of stuff. So again, a good way to go about this is you'll just steal what you already have here. And what I'm going to do is I'm going to highlight that false and paste it in. And then we're not going to see the tool change because we still only have one tool change, but we're going to paste that into those two. And I'm going to go ahead and hit save. Now it's up to you. Just to get a little more fancy here, we could also remove the Y if you just want the table to slide over and get out of the way. So again, Control S as in Sierra to save that. We go ahead and minimize this. And then what we're going to do is we're going to repost, or not post, but we're going to simulate this one more time. And we're going to see those actions take effect. So again, when it comes down to your machine simulation, there's a lot there. And obviously, the more precise your machine simulation can be, the better, right? So I'm going to get flipped back around here real quick. And then let's fire this thing off one more time. How's everything else going out there with you guys? So as we're going to see now, if I orientate myself around, I'm going to slow this down a little bit because if we hit play, we should have went to the home position. But let's go ahead and double check our G code. And it may have a couple other things we'll have to do here to get it done, but let's see what happens when we get to the end. And I'll also throw in a tool change. There it goes. Let's go ahead. Now, I think I saw the problem. Again, Scott, not your fault. We're going to the home position. However, Scott, you'll have to answer me on this. Is the home position on center of this machine? As you guys are seeing, is we are calling the cycle 800 home position. However, it's going to basically XY0, and that XY0 is currently sitting at the center of his table. So again, this is where we have offloaded a bunch of stuff from the post, and we've now put it all in the kinematics tree. So again, let's go in and edit this machine. Give her a few seconds here to load back up. Look at my kinematics tree, and if I look at my Y, you guys can see my home position is set to 0. However, his travel is -5 to +9. So again, this is where at the end of the day, his 0 position is center of the table, which is different than like a Haas or a Fanuc. It tends to be in a specific controller. So again, we're going to go ahead and say minus 5.9 here. And then an X, same thing, we are on center. So let's just go ahead and say minus 7.8 was at 5. And just like that, we've updated the kinematics tree. And if we simulate this one more time, we'll go ahead and see those moves. So it's not still sorting out all the machine sim model. Awesome. As you're seeing right now, Scott, the problem is that your machine in its more or less home position physically here does not match what the actual machine is. But the good news is if you guys are looking at this, our spindle is automatically moved now to the front left corner. Our table would have had moved to the back right corner. And now we're dog-legging over and doing our cut. So again, when we get to the end of this cut, we'll see it here where we now go back over to our home position. So let me know, guys. Is this valuable stuff? Does this make things better? Maybe it makes things worse. Who knows? Again, one more time from the top. I'm going to do this a little different way. We're going to go into the post menu and edit the post. Maybe on your program end, we just want Y. So I'm going to go ahead and remove X. Now, when we simulate this one more time, we should see that it's actually going to come back to us in the X axis and not move in Y. Give this a few more minutes to load up. And we'll take a look at a few other things on that machine sim file side to see if we can't clean it up a little bit more. And this time, as you guys can see, we're running. And it looks like we're still going over in the XY. So I might not have done something proper on my end. But yep, so I must not have removed the home position back to 0. So again, let's go ahead and take a look at a few more things here. So I'm going to go ahead and go in my machine library on this. And what I'm actually going to have to do, we're going to do this a little different way. I'm going to right click on the machine here and I'm going to edit. And now I just want to look at the way this machine was built out. So again, we cannot link to the model that is active. That's fine. Let's just open up the data panel. Now, based on the cheat here, we're going to show the machine. So it is the colored model. What we're going to do is we're going to open that machine up and we're going to check a few things, right? So the reason why there's a lot of additional files coming through with this is because several of these items are still linked at the end of the day. So again, Scott, when it comes down to this, I would highly recommend that you actually break these links when it comes to the way you have everything built out. This is going to make it much easier if you ever have to send me this model again. Again, we're going to go ahead and either capture our position or revert our position. We're going to include all subcomponents. And just like that, we are no longer going to need a lot of these additional files. But let's go ahead and take a look at a few other things here. So you do have the quick change base. You have the TC200. And as some of you are looking at right now, this is what I was referring to when we talk about this is a lot of components here to carry through to do a lot of different things with when it comes to simulation. This is one of those scenarios where I would say you're better off combining these and merging them down to just one solid single body if you can. But let's go ahead and jump back here. Again, one more thing I want to touch on machine sim before we get out of here is when you guys are making edits to your machine, it's very common to do it right here in your setup. But what will happen is in your machine library, now this is something, Scott, you asked me about, is I have what's referred to as the document machine. And you'll also have what's going to be the machine in your cloud. These are two separate items. So just keep that in mind that if you update it in the actual folder or the part file, in this case, documents, the proper lingo, it will not push its updates back to the cloud. So again, make sure that you edit it in the cloud. And that's why they've incorporated the ability to right click and replace machine. And then with that, you can go out and pick your new machine and bring it back through. So again, the question was brought up by Scott is, hey, I made those changes, but I never saw it there. But as you're seeing, Scott is saying in chat right now, yes, because they were not linked from the cloud into the file, the changes didn't come through automatically. Now, A reason why I would point out why that is so important that it's not linked is because there's going to be scenarios where you need to make changes for one-off type things, right? We always recommend to everybody the cloud should retain the like standard. What is the 90% you do? And then the 10% that you need to modify, manipulate, or change, let's go ahead and turn that on when you need it, right? But circling back, we're going to go ahead and jump into a few other things that we have here. So let's get back to that top level of our folder. Now, these couple of other problems that I had submitted to me, again, reminder to all of you out there, feel free if you guys have questions at any time, throw them in chat. Feel free to use the support system down below to send them in. I'm going to keep my eye on the support ticket. Just make sure. Nothing yet. Maybe we're going to get away with a quick one again this week. But let's see here. We were getting some errors. Safe distance is not greater than the maximum step down. So this is a pretty good one, but this is why I always tell people you're going to want to go ahead and read what these errors are, right? Because this is either the safe distance or the maximum step down, right? So what I'm going to do for this file is we're going to go ahead and open up what he has. As you guys can see, it's automatically taken me directly to where the safe distance is. So it is currently, the safe distance is not greater than the max step down. So let's go ahead and look at our max step down here. So we have a maximum roughing step down of 10 millimeters, yet on the other end of the spectrum, our safe distance is 2 millimeters. So basically, it's trying to step down further than the safe distance. So if we actually up this real quick to just 10, as you're seeing, we're still seeing that it's not greater. So let's go ahead and just bump that up to 11. And just like that, it's remedied the issue. Now, the reason why there is what's called a safe, let me get back in here real quick. Safe distance is this is the distance between the tool and the part when it's doing its retracts and linking moves, right? This is not a good example of seeing that because we're not getting a bunch of links up, over, and around. Now, if you were utilizing adaptive clearing on a part like this, let's go ahead and just do a, I can't remember if 2D adaptive clearing has the, where is it here? No lift, stay down. The stay down is a little different here, but the idea is still the same. As if we went in, picked our pocket, and we're going to go ahead and go with that flat end mill. You're going to have times where we're having to pick that tool up and move it over. Now, in this case, we're not picking it up at all because, again, that stay down command is currently set to least. We also have our lift heights, things like that as well that are playing into this. So again, our maximum stay down right now is 2 millimeters, but we can adjust that again. So let's see what our errors change to. Lifting retract height now to a safer height. Again, we need to retract height to be higher than what I'm going to assume is going to be a different scenario. This scenario is going to be based off how I can look at my part. Now, I'm going to pause here real quick. Sal, I have a design question. How can I orientate a surface to be the top without rotating the model? I will show you that here in a minute. Give me a sec, guys. So real quick, I want you guys to look at this. Again, we're now getting the lifting retract height. So what I like to do is retract height is based in Z. It's why I'm looking in what would be the XZ orientation right now. And if I pay attention to the colors give everything away, right? So lifting retract. And if you guys don't know the color coding here, if you rotate a little bit, you'll notice is retract is green. So what I'm looking for is that green line. And what is happening is what we're retracting because of that green line. Now, I do know from a lot of my time out there, the issues tend to come from the fact that we're lifting the retract for certain reasons, but usually it's driven by the fact of our ramp diameters and things of that nature. So again, as you do have a ramp clearance height of 1 meter or 1 millimeter, I apologize. What happens when you're not a metric kind of guy. Again, our retracts are being changed. So again, he's using model top plus 5 millimeters. This is where, again, something simple to do is maybe just pull it up to take a look and see if the error is gone. As you're seeing now, the error is gone. So a lot of this is possibly coming from his linking move, right? So again, we can move that back down. And from that, we should be able to take a look at a few other things. So we do have full retractions on. This could be part of it. We also have a safe distance in here. So again, just working through the problem, small changes if we can. So this is where we were getting that problem before of the 11 versus the 1. Maximum stay down. We have a lift height as well. And I think some people don't realize when you add things together, you also have like your vertical lead-ins plus whatever your ramp clearance height is going to be can all play a factor there. So again, let's go ahead and hit OK, double check that. Lifting retract to a safe height. So where is our safe height setting? We have a safe distance, max stay down, lift height. And we're going to go ahead and do what I like to do, which is the not shortest path, minimum retraction real quick. Just to get our tool down. And yeah, so it's looking like at the end of the day, what I'm going to do in this case is I'm going to recreate this tool path real quick just to make sure something else isn't the problem. And we're going to go ahead and drag that back to the top. I have seen this in the past where sometimes you have changed something and it has caused your own demise, right? So as you guys have seen, I have literally just pulled his tool. Let's go ahead and swap his tool out from 9 back to 2 because that's what he is using. There's also several 2 tools in here. But when I recreated the tool path, all the errors have disappeared, which would lead me to believe that what is happening is being triggered by something in his tool path and something he's changed along the way. And if you guys are looking here right now, notice how my yellow getting down to my part versus his red line is starting up at the top. So as you guys are seeing, we're going to go ahead and highlight both of these using our control button. And then I'm going to right click, compare and edit. And then I'm going to go down to this bottom left and I'm going to say, what is different between these two? Now, there's a lot of reasons why something might be different. Again, we have some different stock to leaves, different bottom offsets, max roughing. All these things are a factor. Now, what I'm going to look for is this little section right here based on linking. This is what I want to see because as you're seeing here, this is where some of those problems could definitely be coming from. And that's where I would start to troubleshoot. Now, at the end of the day, as you guys have seen, I've recreated the tool path. It looks like it works just fine. If I compare and edit, and I'm going to go ahead and say difference, and we have a max roughing step down between these two. So let's say I go to 1 and 0 here. Let's start with that and see what we could have happen, right? So again, as you're seeing, that's making no changes. Again, I think somebody has gone down the rabbit hole of making so many changes to a tool path that we've now led this so far off course that it was easier just to recreate what they were trying to do to fix the problem. Now I'm going to go down a little bit further because there was, again, another safe distance issue, which I would lead back to the same, as well as the lifting retract height to safe distance. So what I'm going to do is I'm going to remove the bad tool path here. And let's go ahead and regenerate this guy now. And let's take a look at what we have. So again, we have those same type of errors coming through. We're doing a pocket toolpath, 3D pocket. And again, that's with tool 5. So let's start with the easiest thing possible. Recreate that toolpath, drag that back up to the top and see if we are still getting that error. We'll give that a second here. Now, some of you are probably seeing, I am definitely getting no errors now. Now, it does look like his tool is staying down a lot further, which again, this is just some detective work that I have going on. And it also, this is where we could do our compare and edit again to be able to figure out what is wrong. So this is what I do on my end, guys, is as you're seeing the safe distance from one toolpath to the other, which is also why there's an error in that toolpath. So if I say 1.3 here, I'm still going to get that error because we're so close to the part in other settings. As you guys are seeing, greater than the maximum step down. What is our maximum step down? Might have to open our windows up here. So again, I'm doing a much smaller step down where somebody else is doing a much bigger step down, right? This is where I think at the end of the day, it's very rare that I make these suggestions, but I think a lot of people really want to go out and use 3D. But the truth is on a part like this, it's still a very two-dimensional part. And people forget that, where instead of trying to fight so hard through the 3D toolpaths, it would probably be better to take this entire thing, no offense to the person that programmed it, but let's just say I would have did everything based on 2D, right? So again, we're going to go with that. I think it was tool 9 was the big flat end mill. My boundary here and here. Now we are getting some funkiness here, which is going to lead me to have some other questions. But as you can see, these are pretty big areas to work with. That is an open chain. See why we got an open chain. We're going to go ahead and convert that to close. And as you guys are seeing now, this is where something about the chain is what's going to make all the difference. Because the moment I selected that lower edge to get it to wrap around the right way, it is now lowered the entire pocket, which means I can't technically do these two with the other two, right? So I'm going to go in. There's my roughing out of that one. I now come back with a secondary adaptive clearing. I need to remedy that little area again. And then we need our inner area. And then I am going to have to, again, based on this design, whoever designed this is definitely somebody that needs a talking to. But I'll show you some tricks, guys. Show you some tricks here. So again, I'm picking those edges, and then I'm going to manually set my bottom height now to what that floor is, right? Now, a trick, if you guys didn't know, is I could, this is a hard could, is you do have the ability, if you went back to design, and some of you are going to hate me when I show you this, is I'm going to actually utilize a split face, right? Now, the reason why I'm going to do split face is because what it will do is it will split the face, but not discombobulate the body all crazy. But if I wanted to split this face and this face based on this face, this is going to allow me to cut those items, right? So, oh, let me do that one more time here. So again, we're going to go split face. I think what's happening is we don't have the fancy dancy extend splitting tool. And now it's dumb, and it's a trick. It's one of those fancy tricks that we have. I now have a chain at the Z height that I want, both here and over here, making my chain selection much easier in the long scheme of. So again, we're still dealing in the world of a body, no additional bodies. Well, in this case, we're not going to get somebody on their design tree right now, but the idea is still the same. We didn't cut this lug off. We didn't cause a bunch of discombobulated bodies, things like that. So what I'm going to do is I'm now going to jump back to manufacture. And when we talk about selecting our chains, I'm going to add in another chain here. That chain is going to run around my part. And if you notice, it is now picked up on that automatically, as well as when we go in to do the chain around this lug. And now I don't have to worry about my Z heights. And I've kind of fixed my own problem on the fly. So again, this is just on a simpler 2D. And I say 2D, when I usually say 2D, I mean like a square part. This is a quick and easy way to get around setting this all up and getting it going. Logged in out there with that's a neat trick. Love to see it, right? So again, this is just a quick way to do this. I can go in, we could do our multiple heights like we talked about. Again, whatever, we're in 2D, so I got to remember that real quick. Max roughing step down, whatever that's going to be, right? I think somebody put 10 was an initial number. So taking that as a full pass with a high feed is a little spicy. I would probably be doing like a 2 millimeter step down here instead. So again, that allows me to do some really cool things here. Now I want to show you guys this stuff, but I'm gonna pause real quick. Sal, are you still out there? I want to make sure I answer your question because I think a lot of people don't realize that there's an easy way to orientate yourself to a face and set it as the front. Let me know in the chat. So, few things. John, we're going to get to that in a minute. Machine specific. I thought your question was machine specific. We'll get back to that. All right, Sal. So real fast here. In the event, let's say, for example, I wanted to look at a specific face. Now, I am going to, there's flats on this. This is going to work good for my example. So let's say, for example, I want to look at a specific face. Down here in your toolbar, I'm going to go ahead and do look at, and then I'm going to go ahead and pick the face that I want to look at, right? And as you can see, it's now squared me up to that face, but my view cube does not match that face, right? So this is where, if you go to this little arrow in the bottom right corner, I can now set current view as top in this case. And as you guys can see, my view cube now matches that part profile. Set it as the top. Yeah, so Sal, as you just saw there, I just reorientated my view cube so that the top is to whatever face I'm looking at. Again, seeing that one more time, I would use the look at button, pick the face I want to look at. And then from there, the little drop down here in the corner, set current view as top. And just like that, I've now orientated the view cube to whatever you're working on, right? Now, pro tip out there for you guys, if you actually go down to the synchronize active setup button, the little yin yang, turn those on. If I hit activate setup, you'll notice my view cube is actually returned off and turned back on to my setup. So let's get back to this a little bit more. Stuart out there with the 5. Love to see it, Stuart. So a few more tips I want to give you guys, and looking forward, can't wait until we get to launch some of our more Milling Monday videos. But did you guys know that your pocket selection is something that you can rinse and repeat across your different setups now? So this is, or not different setups, but different tool paths. But let's say, for example, I want to go from pocket clearing into adaptive, and I want to go down to a 5, number tool 5. In my geometry tab, I can actually go over here and pick those selections. And as you can see, they're now linked between the two. Of course, we got to throw on rest machining from a 10mm tool. But just like that, I'm actually putting my pocket selection, I'm reselecting it and reusing it on the fly. So again, this is a really neat tip trick. Way to get around that at the end of the day is you can tie your different things together. So I'm going to pause here. I did see, all right, machine specific. Let's see. What's your process for troubleshooting Fusion when it locks up on a complex program? 152 toolpaths while surfacing. Happens a lot if I change the order of operations. Auto stock gen is off. Okay. So first and foremost, machine specific, I got to put it out there is 1, I need to know some information about your computer. And it's nothing against a lot of people, but the very first thing I need to know is how much performance are you working with, right? If you're working with 130, 150 tool paths, but you're using a 6-year-old computer, we got to start to point our finger at performance more than it is anything. I would also be open if you want to send the file over here, I'll give it a go. My recommendations at the end of the day, sucks because I don't have actually, this part started off with a bunch. In the event that I needed to regenerate a lot of tool paths, this is a tip that I would give everybody. First and foremost, I would go to my setup and I would right click and I would clear all of my tool paths, right? So by default, I have basically reset all my tool paths. The second thing is he's referring to is he has his stock generation turned off. If you go to utilities, and as you can see in the actions drop down, you have what's called automatic in-process stock. I would turn this off. I would also clear out in-process stock. This is going to make a giant jump in performance because every time you generate a toolpath, it's trying to make that stock happen on the fly. Now, given that I've done all that, what I would look at doing is I would actually use Windows hotkey Shift, and I would regenerate things in batches, right? So the key element here is these first 4, regenerate those. And then once they're up to date, I would then jump down further and fire off another batch. This is something nice at the end of the day that in the world of Fusion, you can create folders, which will help with this quite a bit. Now, something to think about is if I create a folder, I drag it up to the top. Let's just say this is the turning toolpaths. Obviously, you'd be labeling this as, just the roughing. And just like that, I can drag and drop that up into my spot, right? So again, is I can organize things based on file folders and make life a little easier when we start to talk about where is this toolpath, where is that toolpath. Again, this is now my milling or bore. And from there, you can get your toolpaths so that you're only calculating little blocks along the way. I'm going to go ahead and jump down a little bit. You could disable auto generation of the path. Going down a little bit further, it's off. And if you guys are wondering what we're talking about, is if you go up to your preferences, so there's stock auto generation. There is also the ability to go in when you deal with your general manufacturer workspace. I remember, bear with me, automatic generate toolpaths on operation change. This would be another really good one that somebody pointed out, is I would actually turn this off, right? Because I don't want toolpaths to start calculating and bogging down my machine. Again, I'm going to scroll a little bit further, make sure we get all caught up. Manually generate the toolpath, which is tedious, but also it does freeze your machine. So John will go over out there with some questions. Does it work with surfaces too? Bogdan, I need to know what you're referring to. The recent high-end system. So in that use case, I would say machine specific. Feel free to send us an email with the support email address down below. Fill out a ticket and we can look at your specific use case outside of doing it live in front of everybody, right? I will say there is a point, like most things, that you start to hit doing too much, doing way more. I would start to point my finger at, like, how can we get your toolpaths to actually do less with still doing a lot? And that's some of the nice things when we talk about like adaptive clearing. You now have the ability to do, reduce air cutting. There's also the ignoring stock less than, all of that type of stuff. And then lastly, we didn't talk about this, but the amount of RAM you have makes a big difference. I don't know why you could still buy a $2,000 computer and only get 16 gigs of RAM. Asking, okay, Bogdan, so are you referring to avoid touch surfaces? I'll give you a second to answer. Again, getting back to this part, we'll give Bogdan a second to talk. In the meantime, I'm going to go ahead and check the ticket system, make sure that there's no tickets out here. I don't see any tickets at this time. No, can you reuse surface selections? Well, so you can if we're referring to avoid touch surface. And I'll show that to you guys here now. Is let's say, for example, I'm going to do a scallop toolpath on this part. By default, if I come down here in the avoid machine surface area and I generate specific surfaces that I don't want to use, as you guys can see, I can actually right click and create a selection set. And that selection set is now able to be reused later for anything and everything that you're doing. Now, a few other things that you do have the ability to be able to grab across toolpaths. This is going to be a little bit different. Now, you'll notice is I don't have a boundary selection or anything like that, right? So again, let's go ahead and go selected boundary. Let's just say we're going to go around the outside of the part. I can reuse that boundary selection, right? Because that's a chain that I've defined. So if I created we're just going to do a contour. I go in, I say selection. I can go back up. I can grab that selection boundary. Or you could even go up, which is really crazy, is you can grab those pocket selections from the 2D. So the defining of any time that you're using a boundary or a chain type selection, that's in the geometry area, right? You can rinse and repeat those as much as you need. Now, again, this is the luxury of going in and now saying, if I wanted to add some faces here, I can go over to my selection set and select them automatically and pull them inside of the software. So again, let's just Make those our avoid so you see them in red. So the selection set starts to become very, very powerful if you're needing to rinse and repeat and reuse certain things. But it does get better than that because let's say, for example, here, I'm going to highlight these faces. I'm going to right click and actually we're not going to right click. We're going to go over here. We're going to create a selection set and then we're going to highlight these faces. Is you can utilize the idea of multiple selection sets as once. So again, what I'm going to do is I'm going to click the box next to the arrow, which is going to be update, which means now if I go select all those, I can then select the other as well. So again, going back into my avoid touch surfaces, opening up that group 1 in this case, I can go over and select. Now you can see I have 9 faces, which is the original 3 plus 7 more. And just like that, they're all grabbed and put into place in one shot. So again, there's a lot of different use cases for selection set when we talk about surfaces. However, when you guys saw me pick the floor, although that is a surface, that is considered a pocket, not a surface, if that makes sense. So we're going to go ahead and pivot over one more time. Let's see. We got another part file for us to work with. Double angle, again, up in the air. We're going to see what kind of craziness we have going on. Selection sets, I believe, also work at the end of the day, just so you guys know, for edges. It doesn't need to be specifically surfaces. I just want to make that clear that if you had a selection set based on certain edge selections, I believe you can utilize that as well at the end of the day. So if I grabbed all these edges here, we're going to go ahead and update that selection set. In the future, if I want to grab those edges, as you're seeing, I can simply use a selection set to grab them. So getting into this next part, let's get things closed back out here. Believe we can close out that style machine. We no longer need that right now. And let's look at our next part. So I need to pull up the ticket on this and read a little bit more into it. So give me a moment. And actually, we need to go to the other one. So what is the magic with the burring side groove with a double angle cutter? This is going to be interesting. Let's take a look at what we got. So, man, we're going to have to look at this part. I have no idea what we're getting referred to. Stuart, you want to enlighten us here? I'm going to go ahead and jump back to OBS so I can see you guys in chat. John, I appreciate your question in chat. John's question is, anybody else with the inability to get latest when working with model references other than subassemblies? So, John, I would say a lot of that stuff comes down to the location where stuff is. This is why it's much more important to make sure that when working inside of Fusion, as you guys can see, I have a couple of different projects going, but that you're not crossing items across projects, right? Now, I do have my machine sim builds in a little bit different project than my things that I'm working on in this case. However, if we were to go into, for example, my YouTube content, you'll notice, one, I do have all of my different folders and files, but I have machine models in this project for that exact use case. You don't want cross-referencing or jumping from project to project, right? But chamfering underneath. Backside chamfers is what you're referring to? Give me a sec here. Looks like you're boring there. Op 2. All right. Op 2. And let's see what you got. Okay, so you're doing this in the mill and at some... Okay. So your T slot cutting, and now you want to cut this chamfer under here. That's what you want. So again, something that we highly recommend is over here at JIT CAD CAM. When you guys buy through us, if you're a first-time user, we do help you get these projects set up the proper way. Now, again, my recommendation for most of you is the project should still be your company just like your team is. And then if you're a job shop or just a machine shop, you'd have all your customers in here or however you're going to organize your part files. But make sure all of your models in different part files tend to stay together, right? You don't want to be reaching over to another project where your jigs and fixtures sit, because if that jigs and fixture one gets changed or something happens, it's going to affect the files that everything is linked to. So let me get back into my free support Friday real quick. And let's get back over to Stuart's question. So he's in the UK. There is a tool. Awesome. So, but I'm right in my thinking that you want to do the backside chamfer there. So let's see. So there is your tool to do the lower chamfer, I assume. And here is your tool once again to go ahead and, all right, let's go ahead and unprotect this real quick. This is usually when things go south, right, guys? And then we're going to go ahead and not suppress this toolpath. But is this the toolpath you're referring to for this? Now, you are using a form tool. So let's take a look at your form. So you have, based on what I'm seeing here, why Autodesk can't make this window work the same as your viewing point. The problem is going to be, let's see here. Okay, so the edge to define where the toolpath is driven from is that lower of the flat. So we have to account for that distance up and then distance over and down, right? So that's where, if we're going to be doing something like this, I'm just going to go ahead and go a little further. And I do need to turn on stock again, but I want to simulate this real quick and see if we're even touching the. So let's go in. We're going to do the good old fashioned normal simulate. No machine simulation needed here. And it looks like you did achieve what you were going for. Now, knowing the information that you've provided, what I would probably suggest out of the box is, instead of using this lower edge here, you could define it as the center of those two. Now, what that allows you to do is, when doing both a backside chamfer as well as a frontside chamfer, is the distance comped up or down is a universal number, right? Now, I'm going to make some educated guesses here, because in short, the way this was defined, I would be doing, yes, stock to leave the same way you are. Now, me personally, I think the edge selection, you are selecting this lower edge here. That's fine. I might go off of the upper edge. I don't think that's going to make the biggest difference, but it looks like, for the most part, you're on the right track, right? And for some of you wondering out there, what we're referring to is the chain selection makes all of the difference. When you consider, in this case, his chain selection is that bottom outer edge, and then he is going off of the selected contour. And because when we looked at that tool, if you guys remember that red point, Fusion is automatically comping him down and over to make sure that he makes contact with that selected point. So again, he's using stock to leave, presumably to bring the tool up and in, which is going to work pretty good for him. Now, again, there's a lot of ways around this. There's a lot of math involved, but to say the least, is the way you've kind of done it is going to work, but I think your life would be easier. And this is just my take on this. Let's do this here real quick. I'm going to inspect this guy to this guy, and we are going to get that distance of 0.3. When I would do it, I'm thinking I would have selected the same edge. So again, we're using the bigger OD because that's what we use down below. And then I would compensate here that minus 0.3, right? As you guys are seeing, is I'm going to get the same results at the end of the day. And this is also why I'm referring to the fact that when we talk about that tool, instead of used, again, guys, I got to get zoomed in here. Kind of a mess when you deal with it. Had I instead of used the lower point or the upper point, I would have put it right between the two. That way, let's just say that's 3. Again, I would be 1.5 down or 1.5 up, right? That's just the advantage I would have on the math to be able to achieve what's going on here inside of Fusion. So Stuart, let me know, does that make sense to you guys? Do I need to try to explain it another way? Keep me posted and let me know. Can you move it? So the problem is, I don't think you can after you have built it. Now, I could be wrong. I feel like I've done this in the past and we realized real quick it was a bad time. So you got your gauge length. Yeah, so I don't think you can, because the way it's defining that point in space is different than like the tool gauge length and everything of that nature, right? So that's where I think you would have to just recreate it real quick as a live or a form mill as you've done. And then from there, make that adjustment. Could be wrong though. Well, it's going to be bad. You guys are going to see somebody break some stuff today. Nope, you can move it. So if you know that distance, it looks like you can move it based on tip offset. Is a form tool the right way to go? That is questionable. The reason why I say that's questionable is in the case of the profile that you have there for your form mill. If I was to look in the Fusion tool library and build a tool here real quick, Fusion does have either dovetail mills or where is it here? Chamfer end mills. I think a lot of people forget that when you look at some of these, you actually have your taper, your flute length, all of that. But if you were to set your shaft diameter smaller than the diameter of your tool, you do get that modeled backside tool kind of approach. But what you're not getting, as you're going to see, is the flats that yours may or may not have. How would Phil do it? Oh, man, that's a trick question. Well, first and foremost, like I said, the question would be, is that flat on the outside? Again, each their own on that one. But the way I would do it is kind of like I said, I would define the point of reference to be the middle of that flat. And then instead of using possibly contour, I think I would look at using trace. I think trace might be a better outcome for you here, because trace does have that ability. Let me get your tool here. Again, tool 9, you pick your edges. If I could get away with it and set my tool right, I could base everything off simple selections, right? And again, trace does have chamfering, but you could still do, cutter comp left, which is pretty normal. And I would have to go back and adjust that from there. But that would be another way to look at doing it, right? Because where that point is in space does make the difference on how the chamfer mill is going to work. As you'll see right now, remember the lower edge. So again, that's there. And then if we jump forward in our toolpath, now down here, it's the same location, but because you are dealing with an outer and an inner kind of simultaneous thing, that's where you would still need to split this as two toolpaths. But what I'm shifting up and over, I'm just going to shift down and over, right? So that stock to leave positive axial, yep, would be negative on that other pass. But that's me. Who's to say I'm right? I hope you guys prove me wrong. Honestly, I do. So, Stuart, like I said, is what I would literally, again, I would move the point of reference on the form tool. And then what I would do is I would base all my information off utilizing either the bottom height or keeping that 0 now. And then you're just dealing with either a positive or negative axial radial stock. And then because you do it all the time, I would just convert that, store it as a template, and then bring it in and rinse and repeat, right? You just need to know I need to pick the lower rail, the upper rail, right? But try to make those two identical in any way you can. So now that we've gotten to this point, I do have one other thing to work on and show you guys. However, I'm going to open this up to you guys. Does anybody have any questions out there? Does anybody have anything in particular they would like me to take a look at and work on before I shift gears into another example that was provided to me? Going once, going twice. Yay? Nay? All right. You guys are going to get to watch me do some modeling here, which is always a good time. But I'm going to go back to an example I was talking about in the beginning, which was we were talking about an A-axis motion. However, maybe we can't spin 360 degrees, and or we're dealing with a trough with multiple work offsets in place. Now we're gonna look at this from the standpoint somebody does not have dynamic work offset, so we got to program from center to setups, if that makes sense. So what I'm going to do is I'm going to first start off. We're going to do this with components because we have basically the trough. And I'm going to sketch this out extremely dangerously fast. So again, buckle up, guys. This is going to get interesting. Go about 20 inches long, and OD of this thing is going to be, just say 3, which would make 6. Then we're going to make one more rectangle in here. Some of you at home, of course, always questioning what I do. Don't worry, you're not alone. I do the same thing. And I think my wife is in the same boat as you guys as well. So we're actually going to have to make that rectangle a little bit different, but match those numbers. And then this guy is going to come down here. Let's just say it's 1 inch. So we're going to go ahead and do our revolve now around our center line. And then now I'm going to go back and turn on my sketch, and we're going to extrude symmetrical to cut that profile, right? So now I have somewhere for my parts to sit, right? This is a crash course on this for a lot of you. Again, this is where we would look at building out our jigs, our fixtures, components, a lot of fanciness. What I'm going to do right now is just put 2 very simple profiles in here for us to work. But we're going to do the same thing. We're going to go to the top, new component. Let's just say this is our setup 1. And I'm just going to use a box because a box works pretty good at the end of the day for what we need to machine. We'll make that a little longer. Going back to that idea, we can't spin it. And what we're going to do is we are now going to utilize a joint because we are using a component structure. But let's just say I want to do we're going to just normal joint here, here, flip it back the other way. So in theory, this is a placeholder for what would be a part, right? Let's say there's a vise and everything under it. However you guys plan to do your parts, that's on you guys. But I'm actually going to make my life easy, we're going to copy and paste that. Let's say we have another iteration of this part. Again, that's setup 1. Technically, this would actually now be just our part. And as you can see, they're identical items that we're going to work with along the way. But what we're going to have an issue with is when it comes time to machine these is where this part sits in reference to the rotary center is going to differ, right? You're going to get a little variance here. So the question is how do we define it where each one of these are its own work offset, but we still respect center of rotation, right? And this is where you have the ability to use something like a joint origin. And this is where if I had a probing system, maybe I probe top center of stock. And then I know whatever my offset is at the end of the day, I'm going to get this hypothetically close. Because when it comes to machine simulation, I might not be in the market of having to be exact. Again, by exact, I mean anything more than 20 or anything less than 20 thou position in the model is okay. When we're at the machine, it's going to be a little different. But as you guys can see is I could set, I'm going to be a little exaggerated here. There is my joint origin for setup 1. And then again, I'm going to do a secondary joint origin for setup 2. We're going to do about the same thing. We're going to get it pretty close. But let's just say for this use case, back over there a little bit, there is going to be where my work offsets sit. Now, they're very close to center of rotation, but this is where when it comes to the machine sim side of things, I don't need to be exact, right? Even if you modeled this all perfect in the real world, there's a good chance you're still getting 10 thou of problems, as I would say. So let's go to our manufacturing side of things, right? In this case, we're going to go ahead and do our setup. We have our model, which we're going to use our component tree, which is very smart. So there's part 1. Our Z, X, and Y defined as always, Z and X because we are on a fourth. And then we're going to use a selected point for our work offset. So as you guys can see, this is where you would be programming your machine from its center of rotation. But inside of Fusion, the machine that you utilize, and this is where I'm actually going to go steal somebody else's machine, I think. Let's steal this fancy dancy style machine if we can. We're going to copy this guy and we are going to stick it in the free support Friday folder. And let's go back over to that part file. Now you are going to have to save this. So let's get this saved real quick. And let's go back in and make our setup. Give that a second. Again, milling, XYZ, sure. Model is going to be our part 1. And then again, we have our work offset. We're going to go with our selected point, which is our first joint origin. And let's get our machine in here. Give her a second to load up. Now, this is where I'm going to say the accuracy of your machine sim, we could be a little forgiving. I'm exaggerating this, guys. But for machine sim purposes, I'm still putting nothing more than, as you guys will see, is the rotary on center, right? So that trough is mounted on center. However, my WCS system is a little bit off center because what we're concerned about without having dynamic work offset, cycle 800, all of that fun stuff, is that the part in reference to the work offset, all of that G code makes sense. So as you guys can see, that would be my first setup. Now I did forget to grab my jig and fixture. So let me go back in here one more time. Now let's do this one more time here because we're going to repeat this, but we're going to do this for setup 2. I'm also going to turn off the machine because it's going to drive me mad if I don't. So now our actual secondary setup, we go back in, we make a new setup. As you guys will see here, we're going to stay with the same model orientation. We're going to use that other selected point. Means I need to get that turned on. We're going to run back through here. Where is my joint origins? And it looks like it failed to move, so I might have to go back and make some adjustments. And then again, part number 2 in our process, our continuous rest machining will work. And then of course, this time around, again, we want to put that rotary on just like it's going to sit in the machine, right? So again, when we jump from setup 1 into setup 2, got the jig and fixture again. What's always funny is at the end of the day, I think people forget that CAD is very cheap versus machine. So make sure you get stuff set up properly. And I'm going to jump back into design real quick because what is going on? There we go. Where did I put that joint origin? There's the rigid. See, they're both in there. Let's go back. Manufacture. This is the fun. Don't you guys love this stuff? This is what I live for. We have 2 sets of joint origin. We want that one. There we go. Doing this quick. But the idea is now we have our setup 1. Our WCS is coming from center of rotation. We have our second setup where I still somehow forgot to put the jig in here. Jig is not the part, guys. There's the trough. Boom. But now we can run these both at the end of the day from their 2 different kind of WCS locations. Again, these are floating work offsets at the machine. So you're never going to get this absolutely perfect. What we're really concerned about with using the joint origin is to make sure that where that part sits in reference to center of rotation is the most important part of this, right? Now, in the world of machine sim, yes, the more accurate you can get, the better. But given that we are floating right now, I don't even want to measure these 2 because I'll probably be upset at myself. We're a ½ inch, right? Like hypothetically speaking, there's about a ½ inch of variance between these 2. That is a mile in machining. But if we're not doing anything crazy on the machine sim side of it, you, again, very forgiving. A ½ inch would be a lot, guys. I want to just make that clear. We want to see it like within 50. But when you're manufacturing this now, you do your first setup. Maybe I face off the top of this part, go into my cloud library that I very rarely ever get to look at anymore because I'm too busy using your guys' libraries. But let's say we face off the top of this part. Again, I'm going to do that one more time. This time we're going to do some tool orientation. This leads me into something that will probably shock some of you guys here in a sec. We're going to face off the end of this part. Again, I can now jump down further. I did a, hey, we're going to do a 2D contour real quick. Tool orientation. You also have the ability to tie tool orientation between two tool paths. So as you guys will see here, is you can go in and you could say coordinate system, select tool orientation from the other. And then with that, I'm going to go ahead and do a contour selection. So I'm reusing the same tool orientation there. But let's go down to our second setup now. Again, let's do our facing. Let's say you're going to face off the top of this. I know it's just a rectangle, guys. I just want to give you guys some out-of-the-box ideas as to what's going on. But as you're seeing, we would be hitting our trough, all kinds of other problems here. But the idea is when we go to machine sim this, the more accurate, the better. But again, there hasn't been machine sim in Fusion long. Some of us back in the day would have never used machine sim and would be more than comfortable not having it. But as you're seeing, my rotary right now for the trough, because it's mounted perfectly on center, it's swinging around center without any problem, right? So again, using those joint origins, as you're seeing, to generate your work offset location is very, very valuable when you don't have dynamic fixture offset. Maybe you have an old Fidal machine, things like that. I'm going to go ahead and check chat again. I see somebody else asking some questions. I'm also going to clean up my design tree so that you guys can see chat. Machine specific. Can you speak in more details about the best practices and why recommend keeping your models, work holding and machine model in the same project? Yeah, I mean, plain and simple is the best way I could say this. Let's say you own actually, I got one. This is machine shop work. This is be a good one. Let's say you have two toolboxes full of tools. However, some of your tools are on the other side of the shop and your other tools are on the other end of your shop, right? So when you need a 5/8 wrench, you find yourself walking all the way across the shop to dig through a toolbox to find that 5/8 wrench. Now, I don't know about you guys, but when you're in a shop, people grab stuff. It moves. It gets lost. Who knows what happened to it, right? That is why, in my opinion, when you have a situation of two toolboxes at both ends of your shop, it is very similar to the idea of having two separate projects, right? Again, a good way to think about this is both those toolboxes are in the company, but who knows where they're at? Or file cabinets. Again, if you've ever had to go one location to get one thing, but another location to get the other, a good way to think about that would be is like, hey, I had to put these inserts in this end mill and I went in the tool room. But all the tools, those stupid little wrenches they give you with them, right? All of those are in the front office. Well, we all know it's going to get lost, moved, changed. Things are going to happen. That's why when you're jumping across projects, you'll have a lot of problems. Another issue with jumping across projects, because based on who has access to that project and only that project, they can't get the files or make changes or pull those changes through. Again, what we highly recommend, and this is one of those things that if you are a shop that is dealing with a couple of different things that need to be separated, and by needs to be separated, the competition between research and development, engineering and machining, we all know it exists. But you may have three projects, right? You may have the engineering area where they don't want the machinist to see. You may have the R&D lab project for the couple of guys in tool rooms doing some stuff. And then lastly, you may have your machine shop floor with all your other things. You don't want to be jumping across projects. Again, it causes a lot of problems at the end of the day when you jump across projects. This is why we highly recommend, the idea would be is we have the JIT CAD CAM hub. In the JIT CAD CAM hub, I have customers listed here. I am not going to go in there because I don't want you guys to see all those information. But inside of that project now is where all my customer work lives, right? So that's where a better example of this would be is if I go to tickets, now inside of tickets, I have all the folders, and I have folders inside of folders inside of folders. But everything kind of rolls up and stays in this one project, right? Again, machine specific. I don't know how much more I could explain about it or how much deeper I could dive into it. I would, again, never recommend making a project for each one of your customers. As you guys, if you guys haven't created projects inside of Fusion, it is a headache when it comes time to get somebody on your team inside of Fusion. Opening this on the web portal here real quick. You guys will notice here, if it ever loads, is one, you have the projects itself, the members and permissions. Now you have to set up permissions based on who can have access to it. Again, if you have 100 customers and 100 projects, imagine having to go through all of those 100 times to add additional people in, right? Or I can't access, I'm going to pick on the Sile machine again real quick because it's the easiest. I can't access at the end of the day. I can't access the presetter on this machine because it's in a different project, right? I can't access, the part physically itself because it's somewhere else. I can't pull those references. Let me get back over to OBS. Make sure you guys, no further questions. We got Not Tonight in chat again. Not Tonight. Appreciate it. Great to see you again, buddy. But I think things have slowed down. We have been at this for an hour and 20 minutes. I am scrubbing one last time, checking out the support ticket system. I don't see anything. I'm going to, of course, hit you guys with this one more time. As Stuart knows, you guys found something super useful inside of this video or have any questions or any of the above things, feel free to buy me a beer, buy me a steak, buy me some lobsters, whatever you feel necessary. If the hard if, which big bragging rights, right? Outside of the subscribers, the likes, we love all that stuff. We see you guys out there copying and pasting our videos into questions on Facebook, and that helps drive our brand out there, and we appreciate it. Do not need to buy us stuff, but if you feel the need, you don't quite need a full support package, but you need somebody to tear into your machine simulation live and roast you, we're here for you, man. But you could also buy some one-on-one time at any time with us. But, all right. Are you guys ready for it? Scott's about to go to sleep and then wake up in the middle of the night with a million more questions. We all know it. But, going once, going twice. Not what you know, guys. It's who you know. And you all know Fusion Phil over here at JitCAD Cam. We're here to help you guys in any way we can, as much as we can. With that, again, comments down below. Send us support information. If you have problems throughout the week, reach out to us. We will try to get you an answer before the free support Friday session. In the case of Scott out there, he learned that already. We just went ahead and sent him a screenshot and said, hey, buddy, change this one thing on your machine and it'll be good to go. But I still wanted to put this out there for you guys to have. But we hope you guys have an outstanding and amazing weekend. And if you're working this weekend, hopefully it's on Sunday, because I think Sunday is mandatory double time, not time and a half. And we do. That's right. Not tonight. Monday and Tuesday again next week. We are hitting it hard again with Milling Monday, Turning Tuesday. Again, we're jumping into the Heights tab or the radii menu when it comes to the lathe. I hope to see you guys all there. Don't forget, you can go to our channel, get notifications. Feel free to turn them on. But as always, I got some beer to go drink. Have a good one, guys.